Okay, so what I would do here is look for something easy, and I'd look for a rational root. And the rational root I'd look for in the top, because top has the smallest numbers. I would say I would try a real simple one, like one. Does one work? Now, if one didn't work, I have to go through other iterations of the rational root theorem. I don't write all the canons down, but it looks like it's going to work. And what do I say that? If you look at that, that would be 6 minus 1 minus 11 plus 6. And clearly that's going to be 0. I mean, 6 plus 6 is 12, minus 1 minus 11 is minus 12. It's 0. So now I know there's a factor on top of x minus 1. Now, someone says, how can you get the other ones? There's many ways to get it, but I'm going to say that long division is not bad, all right? And by that, I'll put a long division down for you. It's going to be x minus 1 divides into 6x cubed minus x squared minus 11x plus 6. Well, you know what? I'm not going to go through the long division, but I will say this. If you do this, the long division is going to produce 6x squared. No surprise there, by the way. And then you're going to get, let's see, plus 5x minus 6. All right? So then someone says, what are you going to do with that? I'm going to make some attempt to factor it. By the way, I did not do the long division. You need to verify that. Again, you should not trust me when I say that. You should verify that by doing the long division. Let me do the factorization now. 3x, 2x, 2 and 3 plus minus. Let me make sure that works out good. You get 6x squared. 9 minus 4 is 5. Yeah, looks good. So I'll write that down now. What do I get? 3x minus 2 and 2x plus 3. Let me get my eraser out. And again, you need to verify that. Otherwise, you're just trusting me. All right. The bottom, I got to be honest with you. Again, I'm in the same predicament. But here's my deal. It probably has one of those factors. Which one's the easiest one to try? X minus 1. So I'm going to try it on bottom. What am I going to try? Put 1 in. And what do you get? I'm just trying it. Let me make sure you know what I mean by that. I'm going to do just like I did before. Just like I did this on top. I'm going to do it on bottom. What do you get? X equals 1. And you might say it's wishful thinking. It may be. But it doesn't look that bad to do. What do you get? 9 minus 18 plus 11 minus 2. Gee, that worked beautifully. So I now know there's a factor of x minus 1 on bottom. So again, I want to make sure you understand what I'm going to do now. Let me erase all the groundwork we've been doing. I'm actually going to promote long division again. And when you do that, x minus 1, and again, I'm going to encourage it. X minus 1 goes into 9x cubed minus 18x squared plus 11x minus 2. And I know it's quadratic, and someone says, why don't you just do what you did before? I'm just going to there's a variation. There is a variation on this. So what I'm going to say, it's 9x squared. There's a variation in this. Again, you need to verify what I'm going to put here by going along division. Need to verify. So 9x squared. Well, I certainly know the n is going to be plus 2. And that middle guy, I got to think about it. Minus 9. All right. You need to verify that, though. I'm going to factor that now. 3x, 3x, and I got a 2 and a 1. Doesn't matter where I put it. And it looks like minus minus. I'm going to check that, though. That certainly gives me 9x squared. You get minus 3x minus 6x, which is minus 9x, and you get plus 2. All right, so I feel good about that. All right, now someone says, what are you going to do about that? Well, I'm going to do a reduction. And the reduction is going to be, I'm looking for factors identical top and bottom. Certainly x minus 1. Now that cancels provided x is not 1. If x were 1, that wouldn't be canceling. Now let's look for something. Oh, I see 3x minus 2. And this would cancel provided x is not 2/3. If it were, you'd have to do it with 0. So I get an answer. What's my answer going to be? Fairly simple. The answer is going to be 2x plus 3 over 3x minus 1. I'm seeing that right over here. Thank you.